Hi everyone, my name is Yilin and I am a fourth year graduate student at University of Michigan in the chemistry department. My research focuses on protein associated with Alzheimer's disease. I want to know why they behave the way they do and what can we do to alter their behaviors. So today I'd like to talk to you about Alzheimer's disease.
So my topic today is really about history and a short overview of Alzheimer's disease research. What have we learned from it and where are we heading? So I want to first start by talking about the sheer magnitude of Alzheimer's disease. Think about two people that are the same age as you. Now imagine all three of you are 85 years old. There is a very high chance that one of the three of you probably has Alzheimer's. The truth is, 1 in 3 seniors dies with dementia, and Alzheimer's disease is the most common form of dementia. More than 5 million people in the US has Alzheimer's disease, and the number is always rising. It has become the 6th leading cause of deaths in the US. And you might think that you'll be the lucky one among the three. Then you could very well be a caretaker for someone with Alzheimer's disease. Over 16 million Americans provide unpaid care, and almost all of them are family members of the patient. Together, the cost of Alzheimer's disease is just shockingly large. We're not just talking about healthcare cost, which is obviously huge, might break through the trillion mark in just as little as 30 years. But also we're talking about the mental stress that is given upon every single family that has been affected with this disease. So today I'd like to take you for a stroll down a timeline and talk about what we've learned since Alzheimer's disease was first described in history. In 1901, a German physician named Alois Alzheimer described his patient Augusta having a very particular disease. Augusta is a woman who showed memory loss and confusion in her daily life. After Augusta passed away, Dr. Alzheimer discovered that her brain is so much lighter and shrunken compared to everyone else's, and he also found strange deposits in her brain. He described them as plaques and tangles, something he has never seen before in his medical practice. So this disease later is named after this doctor, called Alzheimer's disease. By 1960s, there are a lot more tools that's been invented to allow us to have a better look at the brain, also at the disease itself. After World War II, a fancy microscope called an electron microscope allows scientists to study very, very small things like individual brain cells. This is a picture taken by an electron microscope, and the purple thing that we saw is actually a brain cell. These images help us understand what brain cells look like in someone who's healthy compared to someone with Alzheimer's disease. In the 1980s, the number of Alzheimer's disease cases has really risen in the US to the point that the federal government says, we should really do something about this. So the National Institute of Aging is formed, and till this day, it's the biggest funding source for Alzheimer's research coming from the federal government. There's also a huge breakthrough in this time, being the identification of beta amyloid and tau. These are two proteins that are identified to be very much closely related to Alzheimer's disease. And because the plaques and tangles that Dr. Alzheimer described almost 70 years earlier is formed by these two proteins. So amyloid plaques is formed by beta amyloid, and tau tangles is formed by tau protein. But in the 90s, the first ever Alzheimer's drug was on the market to treat memory-related symptoms. In the next 10 years, 4 more drugs are approved. However, none of them treats the root cause of Alzheimer's because it is still in research, but they do treat symptoms of it. President Ronald Reagan in the 1990s also shared his diagnosis of Alzheimer's disease with the public. This has a huge impact on public awareness of the disease. Starting from the 2000s to the present, there has been a lot of new research and information on Alzheimer's disease, including genetic risk factors, genes that are associated, and there are no doubt that Alzheimer's disease is truly a global health crisis now, since it impacts so many lives and has such a also financial impact too. There are also prevention efforts starting from the 2000s where people are looking at how are you able to spot Alzheimer's disease early in its tracks, and maybe by then the prevention and stopping it from getting worse would be easier. So we learned that the brain really changed very dramatically when affected by Alzheimer's disease. The most obvious difference is the weight of the brain. Patients with Alzheimer's disease has lighter brain because the brain cells are killed and it looks hollower when compared to a healthy person. We can also see where the brain gets most affected. Shrinkage in the hippocampus where new memories are formed, and shrinkage in the frontal cortex where we keep our thinking, logic, and reasoning abilities. And there are many theories on what might cause Alzheimer's disease. A very popular one is an imbalance of the protein beta amyloid. So we mentioned this before, beta amyloid is one of the key proteins identified in these plaques in the brain. And our brain makes beta amyloid, it also cleans it up. However, there are scenarios where more is made and the cleanup can't be followed. So when there's a lot of beta amyloid, they tend to stick together and accumulate. And the reason why they like to stick together is because their structure makes them easier to stick to each other. And very recently, we learned that there is a particular form of beta amyloid sticking together that is especially dangerous. And it's because when 6 of them stick together, they form these barrel-shaped openings. So this is a barrel-shaped opening looking from the side and also looking from the top. And when you see it from the top, you can see from this model that the middle is really hollow. So you can think of it like what it says, a barrel, or you can think of it like a straw with a hollow in the middle. When you put something like that in a cell, it could be on the surface and creates a hole on the surface because it's hollow. So think about like when you punch a straw through a juice box and everything in the cell would just come pouring out because there is a hole now on the cell surface. So the theory is that because beta amyloid tend to adopt this shape, and that's how it gets to kill brain cells. So this is a new direction that allow us to look at where what we can do in this process. Maybe we can stop the shape from forming. Maybe we can break down this shape after it has been formed. So in the end, I want to say that hope is absolutely not lost in Alzheimer's research. It is an incredibly active research area with a lot of attention from both the scientific community and also from the government support, with a $350 million increase in the funding just this year. While scientists are working on a solution to this devastating disease, there are also steps every one of us can do to help lower the risk of Alzheimer's. Through small lifestyle changes, we can really lower our risk of having Alzheimer's disease and live a happy life. Thank you so much for listening to me today, and I hope these informations are helpful to you. Thank you.